Welcome back to our final video in this series about getting acquainted to binomial probability distributions. You have now multiple ways of either graphing, and I'll share this link to my students, graphing binomial distributions. You've got ways of calculating individual probabilities using the binomial probability formula, either by hand using the formula or using Excel. And also, if you play your cards right, you can get Desmos to do it as well. This is the graphing software here. So you've got a lot of tools here for visualizing, representing, and calculating individual or cumulative values in a binomial probability distribution. And of course, remember, you've got the criteria as to whether or not a situation qualifies to be in a binomial distribution or not. So lastly, just a couple quick things to round us out here. We can also say that if we do a lot of experiments, so not just in experiments, but we do in experiments a bunch of times, then eventually the mean number of successes that we get across all of those sets of experiments is NP. So the highest probability, the expected value there, is about, when it's a center, it's mu, it's NP. And the standard deviation, the amount of variation we can expect across multiple sets of experiments, can be found as a square root of NPQ. And we will use that later on, so hold on to that. But don't marry it. Don't stake everything on it. It's only true for binomial distributions. All right. Last thoughts. Let's talk just a little bit about cumulative probability, and this will round us out here. Quick, hard fact here. The higher n gets, each individual result is going to get progressively less likely, even if it's the most likely thing, right? So if I flip a coin twice, the mean result is I get one heads, one tails. That's the expected value. That happens 50% of the time. You can check me on that by listing out all the possibilities. You can check me on that using the binomial probability formula, or you can just trust me. Similarly, if you do 4 coin flips, the expected result, the expected value, is 2 successes, because it's a 50-50 shot. 50% of 4 is 2. But the probability drops to 37.5%. It gets less likely, even though it's the same mean result. And again, you can check me on that using the binomial probability formula. You can list out all 16 different options, heads, 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 all the way down to tails, 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 and you'll get a probability there, a discrete probability of 37.5%. And then you can keep going. You can keep going. You can flip 100 times. Yes, the mean expected value of 100 coin flips is 50 heads. But even though that's the likeliest thing, it's not super likely. It happens about 8% of the time. The remaining 92% of the time, you get something other than exactly 50 heads. So the question becomes, what's rare, right? If our probabilities are dropping the more experiments we get, what is a rare outcome? That's something that's going to be that has been our theme for the past few weeks, our past few video series. It's going to continue to be our theme going forward. What is rare, statistically speaking? Well, before we had statistical rarity if you had 2 standard deviations or more removed from the mean. So actually, without writing this part down, you could look back at your mu value and your sigma value, calculate a mean, calculate a standard deviation, go up or down 2 standard deviations from the mean. That's a way to do it. Another way to do it, maybe save yourself a little bit of trouble, is do some cumulative probabilities. The cumulative probability is the probability of getting your result or something more extreme. So if you're under the mean, if you're under expectation, what's the probability of getting your number of successes or fewer? Conversely, if you're over mean, if you're over expectation, what's the probability of getting X or more successes? And in either event, if your cumulative probability is under 5%, you are statistically rare. And you can check me on this. You can test this. We'll actually do this in class together. But there is a nice correlation between this definition of being 5% probability or less cumulatively and the other definition of being mu plus or minus 2 sigma. It's not a new thing, I promise. So lastly, let's look here at these values. And you should pause before we show the answers. What is significantly rare? Ready, stop, and go. Thanks so much for your time. We'll talk about this in class. Have a good one.